The next section we're going to look at is section 3.3, which is on the multiplication and division property of equality. We already saw this earlier in section 3.2, but if we add or subtract the same amounts to both sides of an equality, it will preserve the equality. The same thing is true with multiplication and division by a non-zero number. So suppose that the number c is non-zero. If a is equal to b, then we can divide both sides by that non-zero number c to both sides of the equation, and it will still keep the quantities equal. Likewise, if a is equal to b, then we can multiply both sides of the equation by the value c, and those things will remain equal. This will give us the method and the means for solving the equations in this section. For example, in problem number 1, we are asked to solve x divided by 5 equals to 9. We know that our goal is ultimately get the solution in the form x equals a number. We want to know what is the unknown number that if I replace x with that number, we get a true statement. In order to solve this equation, we want to remove or get rid of the division by 5. So we think to ourselves, well, what is the opposite of dividing by 5? And the answer is to multiply by 5. So I can multiply the left-hand side by 5 if I also multiply the right-hand side by 5. Our equal sign always comes straight down. And mechanically, the way this works on the left-hand side is if you want to, you can think of the 5 as like 5 over 1. This is now like a multiplication of fraction type problem. So we know that we can reduce 5 goes to itself 1 and 1. And so we get x over 1, which is the same thing as x, equals, on the right-hand side, 9 times 5, which is 45. So our solution is x equals 45. When you're working these out, you don't have to put it over 1. If you've done enough of these, you'll kind of understand what will come to happen. On the left-hand side, we have a multiplication by 5. We also have a division by 5, which are inverses, so they're going to cancel out. And, of course, that'll give us the x equals 45. In example 2, we were asked to solve 6x equals to 30. Keep in mind that whenever we write the variable right next to the number, this is an implied multiplication. To get the x by itself, we would like to remove that multiplication by 6. We can do that by doing the inverse or the opposite operation. The opposite of multiplying by 6 is to divide by 6. And wherever we do to one side, we have to do to both sides. When we divide both sides of this equation by 6, notice that the 6's cancel, leaving us with factors of 1. So we get 1x over 1, which is just x. And on the right-hand side, 30 divided by 6 will give us 5. So our solution is x equals to 5. Let's take a look at example 3. This is a unique problem. I'm actually going to show you two different ways to work this one out. Here, the way it's written, it's 3/4 y, which means 3/4 times y equals to 12. If we take the literal approach we've been doing, we say to ourselves, okay, we need to remove a multiplication by 3/4. The way that we do that is to divide both sides by 3/4. As we've seen before, this multiplication by 3/4 and this division by 3/4 will cancel. So we get y equals the result of whatever this computation is. And let me do this off to the side. This is 12 divided by 3/4. Remember, how do we divide with fractions? Well, we keep change flip. 12 is the same thing as 12 over 1. Division changes to multiplication by changing the second fraction that's behind it to its reciprocal. 3 over 4 becomes 4 over 3. We now multiply. We know that we can reduce this. It goes 1 and 4. And so we get 4 times 4, which is 16 over 1 for a solution of 16. So y equals 16. Again, same concept. We're using the division property of equality in order to get the y by itself. With an example like this, there's an oftentimes faster way that I recommend for my students to do it. And it's kind of based on trying to avoid some of the stickiness with having to write the fraction like this. And the basic idea is whenever we solve for y, so when we had that solution, y equals, right, we want to get it to be 1y. So I want to remove this initial fraction of 3/4. So I want to get rid of it, and I want it to somehow cancel. In order to do that, the other idea we can use here is I'm going to multiply both sides by the reciprocal 4/3. And this is a great technique whenever you have a fraction multiplying to your variable. It's always a good idea to multiply both sides by the reciprocal, which we know we can do, because that reciprocal will cancel with the original fraction. This 4 on the top will cancel with the 4 on the bottom, multiplicatively as 1. Likewise, the 3 on the top will cancel with the 3 on the bottom. And so what we're going to be left with is just 1y, which is y. And then it jumps right to this step, which is simply multiplying 12 by 4/3. And again, it's going to go 1 and 4. And so we get the 16 that way. So the solution is y equals to 16. Let's take a look at example 4. Here we have negative x, which you can also think of as negative 1x, equals to negative 7. So at its heart, what's really going on here is it's technically a multiplication by negative 1. The opposite of multiplying by negative 1 is to divide by negative 1. Whatever we do to one side, we have to do to both sides. Negative 1 divided by negative 1 is 1, so that cancels out, and we just get 1x, or x. And on the right-hand side, a negative divided by negative is a positive. 7 divided by 1 is 7. So our solution to this problem is x equals 7. Let's take a look at the next one. In example 5, this is our first instance of what's called a two-step equation. Because if you look at what's going on in this problem, here's our equal sign. The x is on the left-hand side, and we have a multiplication of 3 and also an addition of 1 that's being present here. In order to get x by itself, we first want to isolate the x term and get the x term by itself. So what that's going to mean for us is we need to get rid of this addition by 1, because this is a separate term on that side that has absolutely nothing to do with the x term that we're trying to solve for. In order to get rid of a plus 1, the opposite operation would be to subtract 1. And whatever I do to the left-hand side, I also have to do to the right-hand side. The equal sign will come straight down. The positive 1 and the negative 1 cancels because they would add to give 0, and 0 plus anything is just that thing. So we have the 3x coming straight down. 7 subtract 1 would give us 6. So this brings us to 3x equals to 6. And then the very next step to get the x by itself, we need to remove or get rid of the multiplication by 3. The opposite of multiplying by 3 is to divide by 3. We divide both sides by 3, and we get x equals to 2. So our solution is x equals 2. We haven't done it in some time, but let's actually go ahead and check this one. Again, with any of the equations you solve, you can check it by plugging in the value for the variable. If everywhere I see an x, if I replace it with the value 2, will we get a true statement? In other words, is 3 times 2 plus 1 equal to 7? And of course it is, right? This is going to be 6 plus 1, and 6 plus 1 is 7. So when we replace x with 2, we get a true statement, and that lets us know that that is indeed the solution to that equation. Let's take a look at another one. In example 6, it's the same kind of idea. We want to solve for the variable. Here's my equal sign. My variable is over here on the left-hand side. This is my y term. In addition to having this y term on this side, we have another term, which is this minus 28, which we want to get rid of first. The opposite of subtracting 28 is to add 28. So we're going to add 28 to both sides. The equal sign comes straight down. The negative 28 and the positive 28 cancel. So on the left-hand side, we're left with a negative 2y equals 4 plus 28, which is 32. We're almost there. We just have our y term on that left side. It's being multiplied by negative 2. The opposite of multiplying by negative 2 would be to divide by negative 2. We divide both sides by negative 2. That will cancel. And we're left with y equals, first of all, it's a positive divided by a negative, which means the final answer should be negative. And then 32 divided by 2 is 16. So final answer, y equals negative 16. Let's take a look at example 7. It's another equals, so it's another equation, but notice how we have the variable on both sides of the equation this time. The first step in the general problem solving procedure is to simplify each side first, which has been true above and is also true now because the left hand side cannot be simplified, nor can the right hand side be simplified. As long as both sides are in simplest terms, the next step would be to move all of the variables to one side of the equation, and we're going to do so by getting rid of the fewer amount. Between a 3x and a negative 2x, the negative 2x is the smaller amount. So I want to get rid of negative 2x's. The opposite of having negative 2x's would be to have positive 2x's. And so we're going to go ahead and add 2x to both sides. On the left-hand side, 3x plus 2x will give us a 5x. Bring down the negative 14 term. On the right-hand side, the negative 2x and the positive 2x cancel, leaving us with 6. So this is what our equation looks like right now. Notice we've successfully moved the x terms all to the left-hand side of the equals. So this is where our attention and focus goes. In order to isolate and get the x by itself, we now want to remove this non-x term, which is the negative 14. The opposite of subtracting 14 would be to add 14 to both sides. Equal sign comes straight down. The negative 14 and the positive 14 cancel. So we get 5x equals 6 plus 14, which is 20. And now we have one more step. In order to get the x by itself, we need to remove this 5, which is multiplying. The opposite of multiplying by 5 is dividing by 5. And whatever we do to one side, we have to do to the other side of the equation. The times 5 and divide by 5 cancel. Multiplicatively is 1, so we get 1x, which is just x. 20 divided by 5 is 4. So our solution is x equals to 4.